Hello friends, let's start the topic relative permittivity or dielectric constant. To understand the topic, we require two charges Q1 and Q2 separated by distance r, and they are kept in a medium known as air or vacuum. This is air, or you can say vacuum. Then the force between these two charges is F naught force is 1 by 4 pi epsilon naught Q1 Q2 upon R square. When the same charges are kept in another medium having same separation in a medium of dielectric constant of permittivity epsilon, then you have force on the medium Fm equals to 1 by 4 pi epsilon Q1 Q2 upon R square. Divide these two forces. Therefore, F naught force in vacuum by Fm force in medium is equals to 1 by 4 pi epsilon naught Q1 Q2 upon R square whole divided by 1 by 4 pi epsilon Q1 Q2 by R square. So here you get 1 by epsilon naught, 1 by epsilon, so it is epsilon by epsilon naught. So this is said to be K, capital K or bold K. So dielectric constant indicated by capital K or bold K. Or you can say this is said to be epsilon r. Epsilon r is relative permittivity. So it is epsilon r. This is equals to F naught by Fm, which is equals to epsilon by epsilon naught. So how we are going to define relative permittivity or dielectric constant? So relative permittivity or dielectric constant is the ratio of force between two charges in vacuum to the force between same charges having same separation in a medium. Or you can also define it, the ratio of permittivity of medium to the permittivity of vacuum is said to be dielectric constant. So since it is the ratio of two forces, so K or epsilon r is unitless and dimensionless quantity. This means that K or epsilon r is unitless and dimensionless quantity. So thus you have learned that definition of relative permittivity or dielectric constant is the ratio of force between two charges in vacuum or air to the force between same charges having same separation in a medium, that is capital K, or you can say it is bold K, or epsilon r is equals to F naught upon Fm. Or you can also define it, this is the ratio of permittivity of medium to the permittivity of free space is said to be relative permittivity or dielectric constant. This means that here you are also going to say that K or epsilon R is equals to epsilon divided by epsilon naught. So you can also write like this. From here you have epsilon R is equals to epsilon upon epsilon naught. This means that epsilon equals to epsilon naught into epsilon R, or you can say epsilon naught into bold K. Since force in medium Fm is equals to 1 by 4 pi epsilon Q1 Q2 upon R square. So this is 1 by 4 pi. At the place of epsilon, write this epsilon naught into bold K. Is a dark, you have to make it dark, it is bold K. So you have Q1 Q2 upon R square. So Q1 Q2 upon R square, 1 by 4 pi epsilon naught is F naught, and here you have this bold K. So you have force on a medium Fm equals to F naught upon K. Memorize this formula. This is very good formula used to find numerical. Let us have a numerical. Suppose you have a charge Q1 is equals to 3 microcoulomb. You have Q2 is equals to 4 microcoulomb. These two charges are separated by a small distance r known as 3 mm. Then what is the force in vacuum and what is the force when we place K is equals to 80. So you have to find first F naught. F naught is equals to 1 by 4 pi epsilon naught Q1 Q2 upon R square, which is 9 into 10 to the power 9. And Q1 is 3 into 10 to the power minus 6. Q2 is 4 into 10 to the power minus 6. Here R is 3 mm, which means that 3 10 to the power minus 3 in meter whole square. Square of 3 is 9. 9 cancel out here. So you have 3 into 4, 12, and 10 to the power minus 3 into 2, 10 to the power minus 6. So 10 to the power minus 6 on numerator cancel out. So 10 to the power this minus 6 and 10 to the power 9 will be add up, and it give you 10 to the power 9 minus 6 is 3 Newton. So this is the force in vacuum. When you talk about force in medium, this become F naught upon K, and this K is 80 given. So you have 12 upon 80, 10 to the power 3 Newton. So you divide it by 4. This is 2020 divided by 4. This is equals to 3. So divided by 2, it is 10. Divided by 2, it is 1.5. So you have 1.5, 10 to the power. This 10 will be cancelled. 110 here. 10, 1.5, 10 to the power 2 Newton. Thus, you find that Fm is less than F naught when the charges are placed in medium such as water of dielectric constant 80, then the force will be reduced. Thus, you have learned what is dielectric constant or relative permittivity. For upcoming video, do like, share and subscribe my channel. Thank you.